Hello and welcome. This is Jim Kaufman with Rankin Technical College. And this video is about understanding asynchronous programming, more from a JavaScript perspective, and more from kind of a node perspective as well, but more, I guess, JavaScript from a JavaScript, I would say from a JavaScript perspective. And I hope that this will help you with your written test, which I think is exam 3 written test on asynchronous programming. So let's get started. So this document delves into core concepts of asynchronous programming, callbacks, Node.js event loop, promises, and async, await, and JavaScript. Explaining how these mechanisms enable efficient and responsive applications. So asynchronous program. So what is asynchronous programming? Asynchronous programming is a fundamental paradigm that allows a program to initiate a potential long-running operation and also continue executing other tasks without blocking. Okay, and that is completely different than how synchronous works. Synchronous is all about a task will be initiated, and then the program's going to wait until that's done until it goes to the next one. It's very sequential, right? But with asynchronous program, you can start a process, and as that is running, you can go ahead and move on to other processes and execute those. Okay. So instead of waiting for a long-running progress to complete, the program can remain responsive to other events and other user interactions. Okay. So from let's just look at from a React standpoint. If you have a React application, it's possible that you'd click a button and something would go and start executing kind of in the background, but then you could still also do other things while that's executing. Okay. And then it would come back and update. It might update that page while you're still working on it. It might update that section while you're still working on it. That's an example of asynchronous programming. Okay. So once the long-running task finishes, the program is notified, and it can then process the result. This approach is crucial for applications that need to maintain responsiveness, such as web browsers, user interfaces, and network applications, where operations like fetching data from a server or performing complex calculations can take a noticeable amount of time. Without asynchronicity, these operations would freeze the entire application, leading to poor user experience. So basically here, we're going to talk about synchronous a little bit. What's the impact of synchronous code on responsiveness? In contrast to asynchronous programming, synchronous code executes sequentially. Each operation must complete before the next one can begin. If an asynchronous task takes a significant amount of time to complete, the entire program could possibly become unresponsive. This means that during the execution of the long-running task, the application will appear frozen. Users won't be able to click buttons, type, or interact with the interface, as the program is entirely occupied with the current operation. This leads to a frustrating and poor user experience, often making users believe the application has crashed. Callbacks. So a callback with JavaScript is a function that is passed as an argument to another function, with the expectation that the callback function will be executed at a later point in time, typically after the asynchronous operation has completed. Callbacks are a traditional way to handle asynchronous results in JavaScript. A common situation where callbacks are still widely used today is handling UI events in event-driven programming. For example, when a user clicks a button, a predefined callback function is executed to respond to the specific event. Similarly, when data is received from a network request, a callback function might be invoked to process that data. While newer patterns like promises and async, await have emerged for managing asynchronous operations, callbacks remain a fundamental concept, especially in environments where event handling is central. Okay. Next thing is talk about the event loop in Node.js. So the event loop is a core component of Node.js's non-blocking I/O model. And when we're talking about non-blocking, we're basically talking about that asynchronous, right? Where basically there's a main thread that gets executed, and then it can still process other things as well, right? So the event loop continuously monitors the call stack and queue of pending task, okay? So the call stack is just a place in memory. So it's monitoring that place of memory and a queue of pending task and the callback queue or message queue. When the call stack is empty, meaning the main thread is not currently executing any synchronous code, the event loop picks up the first task from the callback queue and pushes it onto the call stack for execution. Okay. And I know that might seem a little confusing. Just hang with me. As time goes on, you'll have a better grasp on that. So by doing that, this allows Node to handle many concurrent operations without creating a new thread for each. Okay. So basically, what it's just doing is setting something. It's starting some process. And then while it's starting the process, it's doing other things. But then that main thread will be notified, hey, the main thread will say, hey, the main process is done. You can continue on, okay? The event loop ensures that even though the operations and usually these are ones that take a lot of time. They're very slow. Updating input and output I/O, file I/O, and basically reading and writing files from your computer are very intensive as far as time's concerned. Also, network requests. That's basically like going over the internet. So you're contacting something over the internet. You're waiting for that to come back from an internet call. Are asynchronous. Okay, their associated callbacks are eventually executed when the main thread is free, not safe. The main thread is free. Okay. So basically, to kind of review here, basically it's just saying that there's a process that happens, and when that process gets initiated, and usually the ones that are the ones that take a long time are like file input and output, reading and writing from a computer, from your directory, right? Reading and writing for that, or something over the internet. Them are just take a long time, and you don't really want to have to wait for them. So Node has this event loop that helps with that. And so once what it does is it basically notifies, hey, I'm finished with that. Okay, so then it can move on. Another way to handle a more structured way, promises are a more structured way and robust way to handle asynchronous operations compared to traditional callbacks. They represent the eventual completion or failure of an asynchronous operation and its resulting value. So what is a promise? A promise is an object that represents a placeholder for a result of an asynchronous operation that may not have completed yet. Okay, so a promise basically holds on to it's a placeholder for a result. So it's a place for a result to be, but it may not have that result yet. Okay, it's kind of a promise of a result, right? It sets that result once it has the information it needs. It's a way to handle future outcome of an action that takes time, such as fetching data from a server or reading a file. How do you consume a promise? Promises are consumed using, and we'll look at this more in the future, .then, .catch, and finally methods. Okay, you won't have to worry about this for the test right now, but in the future you will see these kind of methods when we start really working with promises. Okay. So the .then, okay, yeah, maybe we won't go through that. Let's talk about the different states. What are the different states? A promise can be in one of three states. It could be in pending, fulfilled, or rejected. Let me make this bold. So pending, fulfilled or resolved, or rejected. So pending is the initial state. An asynchronous operation is not yet completed, right? A request has been made, waiting for it to complete, and so that promise is in a pending state. The next one is fulfilled. The asynchronous operation completed successfully. It's been either fulfilled or resolved, and the promise now has the resulting value, right? Has the resulting value. The other one is rejected. The asynchronous operation failed, and the promise has a reason for the failure, an error, right? What does pending mean? The pending state signifies the asynchronous operation associated with the promises is still in progress, which kind of already says this before. The promise is waiting for the operation to either succeed or fail. Okay, so in pending state, you don't know if you're going to have a failure, a rejection, or a fulfilled one or resolved, right? Until it's done. It's in a pending state until you have. It's either going to be fulfilled or rejected. Fulfilled is basically a fulfilled state indicates the asynchronous operation has successfully completed. The promise now holds the successful result, which can be accessed through its then method. Okay, so once you'll see in promise code, when we start really working with promises, you'll see a dot then. And so basically, once that promise has that data, the dot then is going to execute the next part of that, what it wants to do with that. Okay. What does the rejected promise state mean? Let me highlight that. The rejected state means the asynchronous operation encountered an error or failed to complete successfully. The promise now holds a reason for the failure, which can be handled using its catch method. Okay. So it's kind of a it's kind of a chain of methods that you have on a promise. You have the dot then, so the dot then gets executed when you're good. The dot catch gets executed when there's an error. Okay. Now let's talk about async functions and await. Async functions and await. The AC function is await keyword. These are both keywords. Let me just highlight them. Async and await. Remember, keywords that are used in JavaScript. So keywords are what's called syntactic sugar. It's built on top of promises, providing a more synchronous looking way to write asynchronous code, making it so it's easier to read. Okay, so that's all you have to really worry about is async and await are a special keyword for asynchronous it's built on top of promises, and it's made for asynchronous code just to be a little more cleaner and easier to understand. Okay, what is an async function? An async function is a function declared with the async keyword. It implicitly returns a promise. So remember, it's async function is going to return a promise. And it allows the use of the await keyword inside its body. So you're going to see async and await together, okay? Not together, right together, but within the same function, okay? What is the main purpose of the async keyword? The purpose of the async keyword is to indicate the function will perform an asynchronous operation and will always return a promise. It also enables the use of the await keyword within the function. What does the await keyword do in an async function? The await keyword can be used inside an async function. When the await is placed before the promise, it pauses the execution of the async function until the promise settles. Okay, either fulfills or rejects. So yeah, that's kind of important to think from that, from that perspective that, a promise is always going to settle. It's going to either be a fulfill or a reject. If the promise fulfills, await returns the resolved value. If the promise rejects, await throws the rejected value as an error. Okay, and as we just looked at here up earlier in the page here, we use the dot then when it settles and does a fulfill. You use the dot then when the promise, if a promise is, well, you're having that in your code, both the fulfill, both the then and the then function and also the catch function. You're going to have them both in your code, and they're going to be set up for if it succeeds or if it fails. Asynchronous functions always return a promise. I kind of said that, I think that's the third time here in this block of code or in this block of statements. If an async function explicitly returns a non-promised value, it will be automatically wrapped in a resolved promise. If an async function throws an error, it will return a rejected promise. So what happens if a promise is rejected in an async function? If a promise awaited inside a async function is rejected, the await expression will throw an error. The error can then be caught using the standard try-catch block within an async function. Just like synchronous errors. If not caught, the error will propagate up the call stack. And well, you guys have all made it through C#. You know about errors propagating up the call stack. Maybe we should review that again later. But it will propagate up the call stack. Just JavaScript's a little different. But it will propagate up the call stack, potentially leading to an unhandled promise rejection. What is the valid syntax to define an async function? So this is an async function. Okay, this is a functional declaration. This is a functional expression using async keyword, and this is an arrow function using async. Okay, and also you can have a method in an object. So as we kind of talked about before on, it was part of the exam 2, the written test 2, that when you have a function that is part of an object, it's called the method, right? A little different thought pattern than what you learned in C#. And here it's just showing an example of a class method where you've created a class and you have an async function there, okay? Async method there. So can multiple await calls be used in a single async function? Yes. Multiple await calls can be used within a single async function to sequentially wait for different asynchronous operations to complete. And this is kind of showing an example of that. Await. So you're waiting for this to complete, each one of these to complete. You got one async with multiple awaits. So when you make this call, this is calling some function in your code, somewhere else in the code, but this will wait. This is going to wait until this is done. It's going to populate this. This will wait till this is done and populate this, okay? But while this is all happening, I know it can be a little confusing. When you execute this code, okay, so this is an async, this will go and start executing, but that don't mean that the main thread in the node doesn't continue on and do other things after this, okay? It's just that this completed function will not be done until all of these calls happen, okay? How can you wait for multiple promises to resolve? Basically, this is how you do that, okay? All right, what is the effect of an await inside a loop? Using await inside of a loop will cause each iteration of loop to pause and wait for the awaited promise to resolve before proceeding to the next iteration. This means the operations will be executed sequentially. While this can be desired in some cases, it can also lead to slower execution if the operations could have run in parallel. For parallel execution of promises within a loop, consider creating an array of promises. And then use promise all. Okay. I know I kind of flew through that pretty quickly. But I think that I touched upon many things that'll be in that written test going through this. So I hope that helps you out. Please let me know if you have any questions. Thanks. Have a good day.